multiplying and dividing rational expressions. Again, this is the exact same thing as with fractions. Let me give you a quick example and a reminder what you did when we had numbers. Like here, 10 over 4 multiplied with 3 over 5. What I'm doing is, strictly speaking, I am multiplying the numerator and then I will multiply the denominators. But of course, I would not multiply this out right now. I would not immediately do this. 10 times 3 is 30, 4 times 5 is 20. This would make my life, this is correct, but this is too complicated. So instead of going big, we are going small. So what I would do is, I look at the 10, I would factor this 10, and I would look at the 4, and I see that 4 can also be factored, because what is happening right now is that I see that there are common factors in the numerator and denominator. Common factors cancel out, and I am just collecting the rest. So what is left here? 3 over 2. This is the exact same thing that we are doing with rational expressions. If I have a rational expression P over Q and I multiply it with R over S, then what I'm doing, I multiply this straight across. Of course, I will always simplify before I write down my answer or multiply this actually out. So let's do an example. We are supposed to multiply 2 divided by x plus 7 with x minus 3 divided by 5. So what I'm going to do, all right, this is multiplication. Now be careful. I have to put parentheses around x minus 3 because I have to multiply it with all of that right thing. And I will have to place parentheses around the x plus 7. So now I'm looking at this and I see that there is nothing really that I can factor any further. X plus 3 and x minus 3 is what we called prime. And then I can just multiply this out. In the more complicated example, we leave it in the factored form, but because this is fairly simple to just multiply out, we're just going to go ahead and do this. So 5 times x is 5x, 5 times 7 is 35. And that is it. Let's do another example. X plus 4 over x minus 7 multiplied with 3x minus 21 divided by 8x plus 32. Again, factoring, factoring, factoring. If there is anything you can factor, then you can factor it. So let's first write it down as before. So what I'm doing, I really multiply straight across. But instead of multiplying this out right now, which would be way too complicated, I am looking at my second factor up here, 3x plus 21. This factor right here can be factored. There is a common factor of 3 that is in both terms. The GCF was 3. I take it out of the 3x, I'm left with the x. And I take it out of the negative 21, I'm left with negative 7. I'm going to do the same thing with this one right here. This also can be factored. 8x plus 32. There is a common factor of 8 hiding in both terms. And if I take out the 8 out of 8x, I'm left with an x. Let's make this a little bit nicer. And 8 divided into 32, or in other words, if I take it out as a factor of 32, I'm left with 4. All right, now I step a little bit back, or I look at my paper if I'm working this out. Then I see right now that there was a factor of x plus 4 in the top and the bottom, and there is a factor of x minus 7 in both numerator and denominator. And that means now all that is left is 3 divided by 8. Let's do another one. X minus 5 divided by x minus 2. We want to multiply this with x squared minus 4 divided by 9x plus 45. So again, I am rewriting everything. But instead of writing now times x squared minus 4, I will immediately take this right here and I will factor this. X squared minus 4, this can be factored. This is, you see how all of our rules for factorizations are coming back in this section. X plus 2 times x minus 2. This was the difference of two squares. And 9x minus 45 can also be factored. There is a factor of 9 in 9x, leaving an x, and there's a factor of 9 in negative 45, leaving a negative 5. Now I'm going to look. This is now the fun part. This is the best part of these problems. I look, there's a factor of x minus 5. There's also a factor of x minus 2. And I just have to collect the rest. I'm just writing down the answer. X plus 2 is the only factor there is. That means I can leave the parentheses of. If you would put parentheses around this, this doesn't make it wrong. This is just not necessary. So we leave those parentheses off. All right, let's do something different. Division. If we are dividing rational expressions, then with algebra we always have these letters. So if we write it down as a rule, P over Q, and I'm dividing this now by R over S, what I'm doing is I just flip the second one around and I get S over R. You might have learned copy.flip or copy, whatever all of these little funny sentences were that helps you to remind that you have to take the reciprocal of the second one. This one is the one that we are just flipping around and we turn it into multiplication. Copy.flip has some sort of a ring to it. Let's do an example right here with numbers. All right, so 18 divided by 12 divided by 3 divided by 4. Remember, this is also nothing else really but division. So this dash right here, this fraction, and this division sign really is the same thing. We will see this later. But what I'm doing now in this problem, I copy down the first fraction, I turn the division into multiplication, and I flip the second fraction around. I take the reciprocal. Now I am multiplying straight across. So in other words, now it's exactly like we did before. And of course you would not multiply 18 and 4. What I would do now, I am breaking this down into as small pieces as I can. 18 is the same thing as 2 times 9, and 9 is the same thing as 2 times 3. 2 times 3 times 3 is the same thing as 18. 4 is the same thing as 2 times 2. What I just did here is called the prime factorization of a number. 12 is 3 times 4. 3 times 4, and 4 really is just 2 times 2 times 3. So now I see all factors. Oh, there are a lot of factors. And what I do right now, I just pair them up on the top and the bottom. There's a factor of 2. There's a factor of 3. There's a factor of 3. And there's a factor of 2. Oops. All that is left is 2. Well, what is left in the bottom? Don't say nothing. There's always a 1. I do not need to write this 1. So in other words, 18 divided by 12 divided by 3 over 4 is nothing else but 2. Let's do this with rational expressions. So if I have the following problem right here, and I'm supposed to divide, then what I'm going to do, I'm going to rewrite this problem, and I'm going to take this one and write it upside down. In other words, well, I cannot really do this with my little tool right here. I'm going to flip it upside down, so to speak. But so that I don't write too much, I will immediately factor if I see something can be factored. X squared plus 5x plus 6, this is the same thing as x plus 2 times x plus 3. 2 times 3 is 6, 2 plus 3 is 5. On the bottom, what I see is the difference of two squares. X plus 5 times x minus 5. Now I turn this division into multiplication, and I am flipping this second fraction upside down. And now what I can do now I multiply straight across. Well, I could already now cancel out, but let me write it down exactly like I did before. Times x plus 2. And you see the only really complicated thing is the factoring. Because now what I'm doing, I'm searching for common factors. I cancel out as many factors as I see that are the same in the top and the bottom. And then I'm just going to collect the rest. X plus 3 divided by x minus 5 is all that is left, and I am done. Let's do one that looks a slight little bit different, just because there will be something like this on the homework. So in this case, I'm dividing a rational expression by x plus 3. Again, difference of two squares divided by x plus 6 over x plus 6. Division turned into multiplication, and now you may think about x plus 3 as x plus 3 divided by 1. This helps to write it down, because then now I see that the reciprocal of this is 1 over x plus 3. If you are ready, you can already cancel this out in this step right now. Now I'm just going to multiply out the rest, what I'm left with. I have 1 times x minus 3 in the top, and then x plus 6 is left in the bottom. And that was the end of our multiplication and division part. We will talk about addition and subtraction of rational expressions next.